All right, let's head to the coast. But, we're not packing our beach towels for this trip. Nope. We're here to dive into one of the most powerful, most dynamic environments on the entire planet. A place that is literally always changing, right before our eyes. So let's get into it. I mean, have you ever really thought about this? You can go to the exact same beach, a place you've known your whole life, and it's never quite the same. One day the sand is here, the next it's shifted. The water's edge is always on the move. So what's going on? Why can't it just stay put? Well, that's the big question we're tackling in this explainer. Okay, so to get to the bottom of why your favorite beach spot keeps moving, we have to zoom out a little and look at the bigger picture. We have to look at the entire arena where this all goes down, the coastline. This is where all the action is. Now, the coastal zone, it sounds kind of technical, but it's not just some line somebody drew on a map. You really have to think of it more like an active battlefield. Seriously. It's this place where land and water are locked in this never-ending tug of war. And it's not just the sandy beach either. We're talking wetlands, estuaries, the water's just offshore, the whole shebang. And this area, it's absolutely packed with life, and it's crucial for our economy. That's exactly why understanding this constant change is so important. All right, so if it's a battlefield, who are the main combatants? Let's meet the major players. The incredible forces of nature that are out there 24/7 sculpting and resculpting our shores. Okay, the three big ones. The heavy hitters are waves, tides, and currents. Each one of these brings something different to the fight, playing its own unique, powerful role. You can think of them as nature's artists, or maybe its demolition crew. It really just depends on the day.
So let's start with the most obvious one, waves. Where does all that incredible energy actually come from? Well, it's the wind. It's as simple as that. The harder the wind blows, the longer it keeps blowing, and the bigger the patch of open ocean it has to work with, that's called the fetch, the bigger and more powerful those waves are going to get.
All right, next up, the tides. This is the slow, steady pulse of the ocean, right? That reliable, rhythmic rise and fall of the sea level every single day. And what's pulling the strings? It's all about gravity. It's the gravitational pull of the moon, and yeah, the sun gets in on the action too, literally stretching and pulling on the Earth and all the water on it.
And, where the sun and moon are relative to each other totally changes the game. When they line up, their gravitational forces team up and bam, you get what are called spring tides. We're talking really high tides and really low tides. But when they're at a right angle to each other, their forces kind of work against each other, they partially cancel out, and that gives us the much more chilled out neap tides.
Okay, so we've got these incredible forces in play, but so what? What do they actually do to the coast? Well, simply put, they create and they destroy. They're constantly building up and tearing down the very ground beneath our feet. Let's take a look at what that actually looks like. You see, waves don't just, splash. They come armed with a whole arsenal of weapons for erosion. First, there's hydraulic action. This is like nature's pressure washer, forcing air into tiny cracks in rocks and just blasting them apart. Then you've got abrasion, which is basically like sandblasting. The waves pick up rocks and pebbles and just hurl them against the cliffs. There's also attrition, which is when all those rocks and pebbles smash into each other, grinding themselves down into smaller, smoother pieces. And finally, there's solution, a slow-motion chemical attack, where the slightly acidic seawater actually dissolves certain kinds of rock over time. And all of this action, this constant grinding and smashing and dissolving, it leads to two basic kinds of coastal landscapes. On one hand, you have the erosional stuff. That's where land is getting carved away and removed. And on the other hand, you have depositional stuff. That's where all that sand and sediment gets dropped off and built up. It's this endless cycle, right? Taking from one place and giving to another.
So on the erosion side of the story, you get some pretty dramatic scenery. Think about those towering sea cliffs. The waves batter away at the bottom, creating these little caves or wave-cut notches. Over time, the cliff above collapses, the coast moves inland, and sometimes you're left with these incredible, lonely pillars of rock out in the water called sea stacks. They're basically just the toughest bits of the old cliff that refuse to give up.
Okay, but what about the other side of the coin, deposition? This is where all that material that got chewed off the cliffs ends up. The currents carry it along and dump it somewhere else, building up brand new features. You get things like spits, which are these long fingers of sand that stick out into a bay. Sometimes they grow all the way across and form a bay mouth bar, sealing off a lagoon. And of course, you get beaches. Beaches are the classic depositional feature. They're basically just giant piles of sand and sediment that the ocean decided to leave there for a while.
This is all fine and dandy when it's just nature doing its thing, but what happens when we decide to build our lives on these moving landscapes? When we put up hotels, houses, and highways worth billions of dollars right on the edge of this chaotic battle zone? Well, suddenly that constant change isn't so cool anymore. It becomes a massive problem. And our natural reaction? We've tried to fight back. We've tried to make it stop.
And our primary weapon in this fight has been something called hard stabilization. It's pretty much what it sounds like. We build big, hard structures, concrete walls, piles of rock, you name it, to try and pin the coastline down and stop the sand from moving. I mean, it sounds logical, right? If the coast is moving, just build a wall. But it's not quite that simple. Let's look at an example. A groin. This is a low wall or barrier built straight out into the water, perpendicular to the beach. The idea is pretty simple, really. Sand naturally moves along the coastline, carried by currents. The groin acts like a dam, trapping that moving sand and making the beach wider on one side.
But, and this is a huge but, there's a catch. The groin actually works a little too well. By trapping all that sand for one section of the beach, it's basically starving the beach right next door. All the sand that was supposed to get there is now stuck. So what happens? The downcurrent beach starts eroding away, sometimes even faster than before. You'd essentially fixed your problem by giving it to your neighbor. And you see this pattern again and again with other structures. You've got jetties, which are like groins but bigger, usually built in pairs to keep a harbor entrance from getting clogged with sand. And then you have the brute force approach, seawalls. These are just massive walls built right along the shoreline, designed to be a suit of armor against the waves. But the unintended consequences, they're almost always there. Jetties cause the same problem as groins, just on a bigger scale. They block that crucial flow of sand. And seawalls? Well, when a wave hits that hard vertical surface, all its energy reflects back. This turbulence scours away the sand at the base of the wall. The very thing built to protect the coast ends up destroying the beach in front of it. It's a classic case of the solution making things worse.
So, if going head-to-head with the ocean, trying to fight it with concrete and rock, just seems to create a whole new set of problems, what's the alternative? This leads us to a much more modern and maybe smarter way of thinking about how we can actually live on these shifting shores.
Well, one of these so-called softer approaches is something called beach nourishment. Basically, instead of building a wall, you just bring in a whole lot of new sand. We're talking barges and trucks full of it, and dump it onto the eroding beach. And hey, it works. The beach gets bigger. But it's pretty much a temporary fix. You haven't stopped the erosion, you've just fed it. The ocean is going to keep on washing that new sand away, which means it's super expensive and you have to keep doing it over and over again. And all of this really points to a bigger shift in thinking, which is captured perfectly in this quote. It's all about finding ways for communities to cope with the change, rather than trying to stop it dead in its tracks. The goal is no longer to build a fortress and hold the line. It's about managing our own development, making smarter choices, so that we can work with the incredible power of the coastal system, instead of fighting a battle that, in the long run, we're probably going to lose. Which brings us to the final, really big question here. We know for a fact that coastlines are not static. They are designed by nature to move, to shift, to change. So the choice we have to make is this. Do we double down and try to build bigger, stronger walls to hold that line no matter the cost? Or do we start learning how to move with it, how to adapt? It's a huge question, and one we're all going to have to answer as the ocean continues its timeless, powerful dance with the land.